a line L. Okay, line L contains the points -5, 3, and 4, -6. We want to find the distance between line L and point P. Think of the picture that we just had. We needed to find the short distance from a point to an already established line. So the first thing we want to do is figure out what line L looks like. So we're going to go ahead and graph that. All right, line L is going to be blue. I'll plot my points. So -5, 3, and 4, -6. All right, so we know line L looks something like this. Okay? We'll label it L. Our first step that we need to do in order to find that short distance, well, first, actually, let's label P. Sorry, point P. So 2, 4. All right, there we go. Now, what we're looking for, per the question, is this purple distance part, okay? We want to figure out what this purple equals, okay? So the first step to accomplish that, we need to find the equation of line L. All right, and I'm going to be shorthanding some of this just to save some space, okay? So, finding the equation of line L, we know that it has to be in slope-intercept form, okay? So we don't have an intercept yet, but we do know that we can find a slope. Okay, remember, if we have 2 points, we can still find our slope. So in order to do that, we're going to use m equals y2 minus y1 over x2 minus x1. Okay, I'm going to label my points as such, so 1s and 2s. All right, and then you just plug in. Okay, so we have -6 minus 3 over 4 minus a -5. Minus a negative, remember that double negative turns into addition, leaving us with a -9 over 9, which reduces to -1. Okay, so we know that the slope of line L is -1. Okay, now think back to what we covered the other day. When we're given a slope and a point, which form do we have to put those into? We have to put that into point-slope form, which I will label right here, PSF. Okay, remember that's your y minus y1 equals mx minus x1. Okay, so in order to fill this out, use the information that we have. We'll use our slope, and I'll just use my points that's labeled 1s, okay? So we have y minus y1, which is 3, equals -1 is our slope, x minus -5, okay? So to clean it up a little bit, we're going to change that double negative into a positive. Right? We then have y minus 3 equals, don't forget to distribute, -x minus 5. Because remember, -1 times a positive 5 is -5. Okay? Last step to clean this up, we are going to just add 3 to both sides. All right, leaving us with an equation of y equals -x minus 2. All right, we're going to need this later. So moving on to step 2, all right, we know we have to have a perpendicular line that goes through point P, okay? So remember, perpendicular, you have to have a opposite reciprocal slope, okay? For step 2, we need to write the equation that is perpendicular to line L and goes through point P. Two comma 4. All right. So for step 2, we have to write a perpendicular line because that's what goes through P. All right. Perpendicular has to be an opposite reciprocal slope. Right? In this case, opposite reciprocal of a -1 is a +1. Right? We're going to use point slope form again. Okay, so this time I'm going to substitute my point P values and my perpendicular slope. Right, so we get y minus 4 equals 1 from our slope, x minus 2 from point P. To distribute, giving us y minus 4 equals x minus 2. Last step, add 4 to both sides. Y equals x plus 2. Okay, so this line right here, this equation we just found, is the equation for the line that goes through point P and crosses through line L. Okay? Remember, the main question that we had was to find the distance, this, right, this yellow. We need to find the short distance between P and line L. Okay? In order to do that, we have to figure out what this intersection point is. Okay? Finding the point of intersection. So find point of intersection between line L and we'll call the purple one line W. So line W. System of equations. Right, so I'm going to color coordinate based on the different lines. Okay, so we have y equals -x minus 2, which is our line L. Y equals x plus 2, which is line W. All right, and then since we are finding, we'll do orange, the solution, or the x-coordinate, we're looking for this right here where they cross. Okay? So to find that, we need to eliminate one of these variables. Okay? Just looking at it, I can already get rid of my x's. Okay, since I have one positive, one negative. In order to do that, you add the two equations together. We get 2y equals, your x's cancel, and then -2 plus 2 just gives you 0. To get our y by itself, you divide by 2. Y equals 0. All right, so this is going to be the y coordinate. So we have 0 equals, I'm going to plug into the purple, x plus 2. All right. We already have the y coordinate, now we just need to find the x. All right. This leaves us with x equals -2. This coordinate right here, this -2, 0, we're going to call this point Q. Okay, so we'll label it on our graph. -2, 0 is point Q. All right, so last step is to find the distance between P and Q. Find distance between point P, remember was our pink one, okay, and remember the coordinates were 2, 4, and then Q is -2, 0. So we have to find the difference, the distance between points P and Q. In order to do that, we have to use our distance formula. Remember that is x2 minus x1 squared plus y2 minus y1 squared. So P will be my 1s, Q will be my 2s. So -2 minus 2 plus 0 minus 4. Take the square root plus -4 squared plus another -4 squared. We're left with the square root of 16 plus 16, giving us a total of the square root of 32. When that is simplified out, we get 4 square root of